In the last class, we started about the chi-square distribution. As I told you, chi-square distribution having two applications. One is to test the independence, second one is the goodness of fit. We have seen in the previous class one example of how to test independence of the two variables. In this class, we will continue with that. We will take another example, we will solve with the help of Python, then we will go for another application of chi-square test, that is the goodness of fit. So, agenda for this lecture is using Python to test the independence of the variables. We will start another new topic, that is application of chi-square distribution on testing the goodness of fit. First we will test the Poisson distribution. This is an example, a record of 50 students studying say ABN school is taken at random. The first 10 entries are shown like this. Why I have taken this example is, in the previous lecture we have got the contingency table directly. The contingency table is given to you. Once the contingency table is given, finding observed frequency and expected frequency, then finding chi-square calculated values are very simple. But in practical, the chi-square distribution will not be given to you directly. Only a Excel data file or some file from database will be given. You have to form the contingency table. After forming the contingency table, then you should go for chi-square test. So, in this example, I have taken one hypothetical problem. There are 1, 2, 3, 4, 5, 6, 7 variables are there. The first variable is academic ability, AA. Second variable is parent education. The third variable is student motivation. The fourth variable is advisor evaluation. The next variable is religion. Next variable is gender. The last variable is community type. This data set is to identify what are the variables that affect academic performance of a candidate. So, here the academic ability is nothing but a test conducted for out of 100 marks. So, this is marks obtained by the candidates. Only I have shown only 10 data set, like that there are 50 data set is there, that I will show you when I am showing the Python demo. The first one is the marks obtained by a student, that is called academic ability. So, that is higher the marks, higher the academic ability. The next variable is the parent education. The question is asked to the parent, how many years you spend on the schooling. Generally, parent education is a categorical variable, but instead of capturing categorical variable, we have got that variable in the form of interval, kind of a continuous variable. What we have asked to the parent, that how many years you have spent in the schooling, say 5 years, 6 years and so on. So, now the parent education will become a continuous variable. Then student motivation, we have asked the student, suppose if you want to study, if you want to get more marks, are you willing to spend extra time for the study? 1 means no, 0 means not decided, 2 mean yes. Advisor evaluation, advisor is like kind of a faculty advisor. That faculty advisor can say whether this fellow will pass in the examination or he will do good performance in the examination. 1 means will not do, 0 means not decided, 2 means will do the good performance in the examination. Then R is the religion. There are 3 categories of the religion, 0, 1, 2. This is the explanation of the variables. For example, as I told you, the first column is RES, respondent underscore number, kind of a registration number. AA is academic ability, P is a parent education, SM is a student motivation, R is the religion, G is the gender. I have brought the screenshot of Python. We have imported pandas and numpy, then we imported the data set. So, this was the data set. You can see that there are different variables, academic ability, parent education, student motivation, advisor evaluation, religion and gender. So, I have imported the data set, the data which I have stored in this file name academicability.data.csv file. So, this was the output of the data. Now, we are going to have the hypothesis, test the hypothesis that the gender and student motivations are independent. Now, we are going to see, is there any connection between the level of motivation and their gender. In many cases, we presume that the girl students are highly motivated than the boy students. It is a perception that we will test it whether is there any connection between gender and the motivations. So, the null hypothesis is that the gender and student motivations are independent. Alternative hypothesis is it is not independent. The hypothesis which we are going to test is gender and student motivations are independent. That is our null hypothesis. This is a very important command for forming our contingency table. Otherwise, call it as a cross table between gender and student motivation. So, you see that pd.pivot_table, the file name ACAD, G is the gender, SM student motivation, index G should appear in row, column should be the SM. So, aggregate function is length. So, after you run this, we are getting a contingency table. In contingency table, here what is there? It is the gender. So, in column it is the student motivation. The previous table which are shown in here, just I have wrote in the presentation. In the rows, say 0 means it is a male, 1 means it is a female, that is a code which I have used for gender. The student motivation, there are 3 level, one is 0 disagree. The question which I have asked is, are you willing to spend extra time for getting more marks? 0 disagree, 1 not decided, 2 agree. So, I have seen the row sum, there are 29 male students, there are 21 female students. So, 0 people, 14 students have told that they will not spend extra time. 22 people have decided that told that they have not decided whether they should spend extra time to study or not. So, 14 people have agreed that they will study, they will spend extra time. Now, you see that in row there is a one variable, in column there is another variable. The null hypothesis is the gender and the student motivations are independent. We know that the cell, the 10, 13, 6 represents the observed frequency. Now, we have to find out the expected frequency for each cell. The expected frequency is, as I told you in the previous class, that row total multiplied by column total divided by overall. So, see previous one 29 multiplied by 14 divided by 50. So, this 8.12 is the expected frequency. Similarly, for this also we got 12.76, 8.12, 5.88, 9.24, 5.88. One important assumption that the value of the expected frequency should be more than 5. In all the cells, the expected frequency is more than 5, then we can continue for our calculation. So, I have wrote FO represents observed frequency, FE represents expected frequency. So, for each cell we know that what is the observed frequency and expected frequency. Now, we have to go for chi-square calculation. We have seen that formula, chi-square is calculated value is nothing but observed frequency minus expected frequency whole square divided by expected frequency. So, when I go back, the first cell observed frequency is 10 minus 8.12 whole square divided by 8.12, we will get 0.435. Like this, when you do for all the cells and sum it, the calculated chi-square value is 2.365. This Python code shows chi-square calculated values. For that purpose, we have to import chi-square underscore contingency. You see that chi-square comma p comma degrees of freedom comma tbl equal to chi-square underscore contingency, the observed values. Then when you type chi-square, we are getting 2.364, the p value is 0.30. Since the p value is more than 0.05, we have to accept null hypothesis. When we say accept null hypothesis, we are concluding that the gender and the level of motivations are independent. Then you can get the degrees of freedom value also. As I told you, the degrees of freedom is number of row minus 1, 2 minus 1. There are 3 columns, 3 minus 1 is 2. That is a 2 value. This is the degrees of freedom. Then This is contingency table where you can get the expected frequency. When you type TBL, you can get the expected frequency. You see that the 8.12, this was the, you will go back, see 8.12, 12.76, 8.12, that value which we got it manually, we can directly get with the help of Python. So far I have shown the screenshot of our Python programming and explained how to form a contingency table, then how to do the chi-square test. Now I will go to Python prompt, there I will explain how to import the data and how to do the chi-square test. I am going to explain how to form a contingency table from the Excel file, then doing the chi-square test. Import pandas as PD, import numpy as NP. I have imported, I have stored my data set in the file name called acad.xlsx. So first I have to run the pandas, yes. Now let us see what is the data set. That data set, you see that there are 49 plus 0, there are 50 data set is there. There is a respondent number, academic ability, parent education, student motivation, advisor evaluation, religion, gender and community. We are not going to consider all the variables for our calculation. We are just going to consider only the gender and the student motivation. Okay. Then we will form a contingency table for that. This is OBS PD dot pivot underscore table academic ability, that is the file name, column G and student motivation, and the index in row I need to have the G value, that is the gender value, in column I need to have the student motivation value. So when I see this data set, you see that the output shows that directly I am getting contingency table, because when I am explaining theory, what happened, the contingency table is given to you, but many times that will not the case. The data may be in some other format, you have to create a contingency table before doing the chi-square test. So this command is helping in Python, this command is helping us to form the contingency table and it saves lot of our time. So this was the contingency table. This the value in the cell represents the observed frequency. So what this 10 represents, when the student level of motivation is 0, the 0 represents male. This is the 10 is our observed value. Then import chi-square contingency library. Then we will write chi-square comma p comma degrees of freedom comma tbl equal to chi-square contingency this OBS. This OBS is where our contingency table is stored. So when you run this, now the contingency table was run. Now we want to know the chi-square value. The chi-square value is 2.36. This was the chi-square calculated value. Then we can know the p value. The p value is 0.30. Look at the p value which is more than 0.05. So we have to accept our null hypothesis. When I say accepting null hypothesis, I am concluding that the gender and the student motivations are independent. There is no connection between the gender and the level of motivation for the student. So we can get to know the degrees of freedom also directly with the help of this command dyf, and then TB1, this give you your expected frequency. If you are doing manually, you can compare this expected frequency. So this was the answer which I have shown in my presentations. So far we have seen the first application of chi-square distribution, that is test of independency. Now we are moving into another application, that is testing goodness of fit. What is the meaning of goodness of fit? Many times when we collect the data, we have to know what distribution this data follows. So the chi-square test is helping us to find out, to know what is the distribution this data follows. First we will take an example of Poisson data, then we will check this whether this data follow Poisson distribution or not. What is the chi-square goodness of fit test? Chi-square goodness of fit test compares expected frequencies of categories from population distribution to the observed frequencies from the distribution to determine whether there is a difference between what was expected and what was observed. So what we are going to do, as usual, we are also going to see expected frequencies and observed frequencies. We are going to see is there any difference, is there not. The formula is same, the chi-square value is observed frequency minus expected frequency whole square divided by expected frequency. The degrees of freedom, this is different from previously what we have seen. In contingency table, the degrees of freedom is number of rows minus number of column. Here the degrees of freedom is k minus 1 minus p. The degrees of freedom is k minus 1 minus p, where the k is number of categories, number of observations we can say, number of categories. Here p is number of parameter estimated from the sample data. The number of parameters you should know in advance. For example, if it is a uniform distribution, parameter is 0. If it is a Poisson distribution, the parameter is 1, that is only the lambda value. If it is a normal distribution, the parameter is 2, because normal distribution is having two parameter, one is mean and variance. Now let us follow some steps to test the goodness of fit of a given data set. Now assume that then some data set is given to you. We are going to test whether this data set follow Poisson distribution or not. The first step is set up the null and alternate hypothesis. What is a null hypothesis? Population has a Poisson probability distribution. What is the alternate hypothesis? Population does not have the Poisson distribution. Here one important point you have to see, so far whenever we see the null hypothesis, we say that then the term not will appear in the null hypothesis, but only in the goodness of fit test it is the reverse. You see that the given data follow Poisson distribution, that should be our null hypothesis. Alternate hypothesis is the data, the population does not have a Poisson distribution, it is the just reverse of that. For all kind of hypothesis testing, the word not will appear in null hypothesis. Only for the goodness of fit test, the word not will appear in your alternate hypothesis. This is one important difference that you have to remember. Select a random sample and record the observed frequency, call it as Fi, from each value of the Poisson random variable. Compute the mean number of occurrences mu, because we should know the parameter of Poisson distribution mu. Compute the expected frequency of occurrences, that is the Ei, for each value of the Poisson random variable. Then compute the value of test statistics. This is as usual, observed frequency minus expected frequency whole square divided by expected frequencies. Remember here also the value of expected frequency should be 5 or more. If the expected frequency is not 5 or more, you have to collapse certain intervals and you have to make it so that the expected frequency is 5 or more. We will see that example also here. There are two ways for rejection rule, p value approach. Reject h naught if the p value is less than or equal to alpha. If you are following critical value approach, reject h naught if the chi-square calculated value is greater than your chi-square critical value which you got from the table, where the alpha is significance level and there are k minus 2 degrees of freedom. You should remember how this k, because it has come k minus 1 minus p, because Poisson distribution having one parameter, only mean is the parameter for the Poisson distribution. So the value of p is 1, so it has become k minus 2. We will take an example. See parking garage example. In studying need for an additional entrance to a city parking garage, a consultant has recommended an analysis. Consultant has given some solution. That approach is applicable only in situations where the number of cars entering during a specified time period follows Poisson distribution. Since the consultant has given some solution, that can be implemented only if the arrival follow Poisson distribution. A random sample of 100 1-minute time intervals resulted in customer arrival listed below. A statistical test must be conducted to see if the assumption of a Poisson distribution is reasonable. So what is given? A number of arrival is given, the frequency is given. So 0 arrival, the frequency is 0, 1 arrival, the frequency is 1, 2 arrival, the frequency is 4, 3 arrival, frequency is 10, like that up to 12 arrivals is given. we will form the hypothesis. What is the null hypothesis? Number of cars entering the garage during 1 minute interval is Poisson distributed. Alternative hypothesis is number of cars entering the garage during a 1 minute interval is not Poisson distributed. You see that this is different from our traditional way of making null hypothesis. Generally the term not will be there in the null hypothesis, but here where the goodness of fit test, the term, the word not will appear in our alternate hypothesis. This is the Python code which I have taken the screenshot. Import SciPy, import chi-square, import Poisson. The data set is I have kept in the file name called p underscore distribution. This was the arrival, this is the actual frequency. Otherwise we can call it as observed frequency. The next term, we should know mean of the data set. Estimate of Poisson probability function. See the total arrival, the mean formula, we know that the same simple formula, mean is mean mu equal to sigma fn divided by sigma f. So f is the frequency, n is the number of arrival. So 0 into 0 plus 1 into 1, like that there will be a value will be 600. So sigma f when I go back, you see that this frequency, when you add this frequency, that will be 100. So that value is 6. So the 6 is the your mean. We know that our formula, traditionally what is our formula? So the formula is e power minus mu power x, otherwise some people call it as lambda, e power minus lambda into lambda power x divided by x factorial. So here mu is your 6, so 6 to the power x, e to the power minus 6 divided by x factorial. Now what we have to do? We have to substitute these x values. Then after, if you substitute these x values, you will get a theoretical frequency. So when x equal to 0, f of x is, when you substitute in this equation, when x equal to 0, 6 to the power 0, e to the power minus 6 divided by 0 factorial, that is 1. So e to the power minus 6 is this 0.0025. This is a probability value. We want to know in terms of frequency. So that has to be multiplied by n is 100. When you substitute x equal to 1 in this equation, 6 to the power 1, e to the power minus lambda divided by 1 factorial, you will get 0.0149, then multiplied by n. So this value will give you the theoretical frequency of our Poisson distribution. Like that we have to have up to 12. You see that here the theoretical frequency, when you look at this 0, 1, 2, these values, see that this is less than 5, so this has to be added, this also less than 5. So these 3 groups has to be grouped. The same way you see that this is 6.8, here what is happening, these values are less than 5. So these values has to be clubbed so that the expected frequency is 5, that is what we have done that one. Okay. So we got the observed frequency, we got that mean value, then for each x value we got our expected frequency value by using the for loop. Okay. So then we will do round off, this was our rounded value using Python. When you look at this 0.25, you go back 0.25, 1.49, you will get the exact the same value. Now we are going to have only 2 columns, one is observed frequency, next one is expected frequency. You see that 0 or 1 or 2, so that are clubbed so that the expected frequency is more than 5. Similarly 10, 11, 12, these are grouped together so that the expected frequency is 8.39, otherwise it will become less than 5. Now how many number of intervals there? 1, 2, 3, 4, 5, 6, 7, 8, 9 interval is there. Now this is observed frequency, expected frequency. Now If you directly you can run this command, that is scipy.stats.chi2 observed frequency minus expected frequency, that we are getting 3.27, the p value is 0.911, that is more than 0.05. So, we have to accept a null hypothesis. When we accept a null hypothesis, we are concluding that the given arrival pattern follow Poisson distribution. You see that for rejection rule, when alpha equal to 0.05, k, we got k equal to 9, as I told you, because 9 interval, I am going back, I will explain 1, 2, 3, 4, 5, 6, 7, 8, 9 interval, that is why here k equal to 9. P is the number of parameter, as we know that Poisson distribution having only one parameter. So, it is 9 minus 1 minus 1, so 7 degrees of freedom. For 7 degrees of freedom, when alpha equal to 0.05, we can get the chi-square table value is 14.06. See, when you look at the chi-square calculated values, it is 3.268. So, this value will lie on the acceptance side. So, we have to accept, because the chi-square distribution will be like this. So, this is 14.067, your 3.268 will be here, it will be lying on the acceptance side. See, we have to accept a null hypothesis. The same thing, we are 0.95, 7. So, the chi-square calculated value is 14.06, see that 14.06, but not calculated value, the chi-square table value is 14.06, but our calculated value is 3.26. So, it is lying on the acceptance side, do not reject null hypothesis, then we will conclude that the arrival pattern follow Poisson distribution. In this class, I have explained how to form a contingency table. After forming contingency table, how to do the chi-square test with the help of Python. The next topic which I have started, testing goodness of fit. Suppose if some data set is given, if we want to test what distribution it follows. I have taken some data set, then I have tested whether this data set follow Poisson distribution or not. I have explained the Python screenshot. The next class, I will run the Python code for testing Poisson distribution for given data set, and I will explain how to test goodness of fit for uniform distribution and normal distribution. That we will see in the next class. Thank you.